The topic is adding and subtracting unlike fractions. The objectives in this topic are add or subtract unlike fractions, write fractions in order, evaluate expressions given fractional replacement values, and solve applications by adding or subtracting unlike fractions. So the steps of adding or subtracting unlike fractions are to find the least common denominator of the fractions, write each fraction as an equivalent fraction whose denominator is the LCD, then add or subtract the new like fractions, finally write the sum or difference in simplest form. So we've done each of these things individually. Now we're going to put it all together. Now, in a previous class, we saw how to check if two fractions were equivalent. For instance, 2/4 and 6/12. How do we check if two fractions are equivalent? We cross multiply, something we can do over an equal sign. 4 times 6 is one leg. 2 times 12 would be the other leg. And since we get the same answer on both sides, that means that 2/4 and 6/12 are equivalent fractions. Notice equivalent fractions will be able to have a consistent pattern across the top and across the bottom. If the bottom takes times 3 to get to the second, 4 times what is 12? 4 times 3 is 12. That means the top will have the same thing. 2 times 3 is what gives us 6. We're going to use this method to create an equivalent fraction with a given denominator. So this next question is going to give us 3/5, and it's going to say, write the fraction as an equivalent fraction with the denominator of 15. So it's going to look like this, and we have to give the missing number from the top of the second fraction. In order to do this, we have to ask ourselves, what do I multiply by 5 to get 15? And I'll say, well, self, 5 times 3 is 15. So what do we do on the top? Times 3. 3 times 3 is 9. The missing number is 9. The equivalent fraction is 9/15. Let's do more with this. Mean trick, right? 7 equals something over 3. Well, for starters, we need to rewrite. We see the whole number, but we're working with fractions. We know 7 is 7 over 1. How do we get from 1 to 3 with multiplication? 1 times 3, 7 times 3, it'll be 21. 21 is the missing number. 21 over 3 is the equivalent fraction. I don't want you to leave this with the impression that it's always going to be times 3. Today's flavor is black cherry vanilla. It's not always times 3. 1/2 equals something over 22. How do we get from 2 to 22? That's times 11. So on top, we have to do times 11. 1 times 11 is 11. Missing number 11. Equivalent fraction 11/22. Another one. 5/6 equals some number of 36. What's the missing number? To get from 6 to 36, we times 6. To get from 5 to the missing number, that means we also times 6, and 5 times 6 is 30. Missing numerator is 30. Equivalent fraction is 30/36. I'd like to take a look at 1/5 plus 1/10. This is the first addition of fractions problem we have where the numbers on the bottom are not the same. And therefore, we cannot add these yet. This is not 2/15. This is not 2/5. This is not 2/10. In order to add two fractions that have different numbers on the bottom, we need to use least common multiple to find what the common denominator is going to be. And then we need to use equivalent fractions to make sure both of these are rewritten with that common denominator. Once we have two fractions equivalent to what we were originally given, that both have the same number on the bottom, we can go ahead and add like we did in the first part of class. So 5 and 10, we need the least common multiple. 5 is just 5. 10, prime factorization would be 2 times 5. So the least common multiple is every base, 2 and 5, to the highest shown power, 2 to the first, 5 to the first. So it's just 2 times 5, which is 10. We need to rewrite both of the original fractions then with a denominator of 10. The second fraction already has 10 on the bottom, so it's just 1/10. This fraction is already good. But the first one needs to be changed. So ask yourself, how do we get from 5 to 10? That's times 2. So we have to do times 2 for the top as well. 1 times 2 is 2. So this addition problem is the same as 2/10 plus 1/10. So 2 plus 1 over 10 gives us our final answer of 3/10. So you can see adding fractions is a lot more complicated than multiplying. We can't add or subtract until we have the same number on the bottom. Let's look at another. Let's look at 1/6 plus 1/5. The numbers on the bottom are not the same, so we cannot add yet. This is not 1/6, it's not 1/5, it's not 1/11, it's not 1/30. We have to do least common multiple for the bottom numbers, least common multiple of 6 and 5, and then do equivalent fractions. Prime factorization of 6 is just 2 times 3. Prime factorization of 5 is just 5. For the least common multiple, it's every base we have to the highest shown power. We have 2, 3, and 5. Highest shown power of all of them are just first power. So the least common multiple will be 2 times 3 times 5, 6 times 5, which is 30. So the new denominator for both fractions has to be 30. We don't just bring these ones down. It's not 1/30 plus 1/30. Neither of these is going to be 1 because we have to change the bottom numbers, which means we have to change the top numbers. How do we go from 6 to 30? That's times 5. So 1 also times 5. 1 times 5 is 5. How do we get from 5 to 30? That's times 6. So 1 times 6 is 6. 1/6 plus 5/6, or sorry, 1/6 plus 1/5 is therefore 5/30 plus 6/30, which is 5 plus 6/30. Our answer is 11/30. So neither of the original fractions could stay the way they were because both had to change denominators. Next up, let's look at 7/11 plus 7/22. Maybe you notice right away that 11 times 2 makes 22, so 22 can be used. If not, let's see how we get that common denominator of 22. We want the least common multiple of 11 and 22. Prime factorization of 11 is just 11. Prime factorization of 22 is 2 times 11. Least common multiple would be every base we have, which is just a 2 and an 11, raised to the highest shown power. 2 is just 2 to the first. 11 is just 11 to the first. 2 times 11 gives us the least common multiple of 22. 22 will be the new bottom number. And then we could notice, hey, this one's already over 22. We don't have to change that second fraction. It's already with the bottom number, the denominator that we want. For the first fraction, though, 11 to 22 is times 2. So we have to do 7 times 2, and it becomes 14/22. 7/11 and 14/22 are equivalent fractions that we've made. These we can add because they have the same number on the bottom. So this is 14 plus 7 over 22, which is 21 over 22. Another one. This isn't so bad. Like I said, more difficult than multiplication, but still we have a step-by-step process. 5/14 plus 3/7. We need the least common multiple of 14 and 7. 14 is 2 times 7. 7 is just 7. Least common multiple is every base we have to the highest shown power. We have 2 and 7. 2 only gets raised to the first power. The 7 only gets raised to the first power. That's 2 times 7, that's 14. Both of these fractions, therefore, need to be written over 14. That means we don't have to change the first one. It's already over 14. But the second one needs to change. 7 to 14 is times 2. So we do 3 times 2. That's 6. We can add these. They both have 14 on the bottom. So this is 5 plus 6 over 14, which is 11/14. Another one, we're drilling this process into our brains. Process is not changing. 7/6 plus 1/3. Instead of going that whole least common multiple route, I want to show you this. We can multiply anything by 1 without changing it, right? So what if we multiplied this fraction by 2 over 2? Then we can see that this is 2/6. You can do this if you notice that one of them multiplied by something else gives us the second. And then 7 plus 2 over 6, 9 over 6. 9 is 3 times 3, 6 is 3 times 2, the 3's cancel. 3/2 is the answer. Or just the long way. Least common multiple of 6 and 3. 6 is 2 times 3. 3 is just 3. Least common multiple would be 2 to the first times 3 to the first, which is 6. We rewrite both fractions as being over 6. First one doesn't have to change because it's already over 6, but 3 times 2 is 6. 1 times 2 is 2. 7/6 plus 2/6 is 7 plus 2 over 6. 9 over 6 reduces to 3/2. Okay, let's do some more interesting ones. No more of these easy, not having to change one of the fraction problems. Let's do 2 over 21 plus 6 over 35. We need the least common multiple of 21 and 35. Which means we need the prime factorizations of 21 and 35. 21 would work out to 3 times 7. 35 would work out to 5 times 7. So least common multiple. All the bases we have a 3, we have a 5, we have a 7, all just raised to the first power. So that's 3 times 5 times 7, which is 15 times 7. Carry the 3, which is 105. So we need to rewrite both of these fractions with a denominator of 105. This is why, in addition to just reducing, we spent so much time with prime factorizations in that one class. You have to know how to do it. And you have to know how to multiply. All of these lesser included skills in adding and subtracting fractions, we've done building up to this. This isn't a class where, oh, I didn't know how to do this, but it's okay, we're going to do something different. No, you need to know how to do everything we've been learning, because every bit of that is a required skill for something else. And then once we're done with fractions, you need to know how to work with fractions for everything else that we do. So this number is big, but that doesn't mean that we change the process. We just need to know how to get from here to here. 21 times what is 105? Well, I don't expect you to know that offhand. That's why we know how to divide. 105 divided by 21 will give us the times what? 21 goes into 105 some number of times. 20 times 5 is 100. So is it times 5? What's 21 times 5? 5 times 1 is 5. 5 times 2 is 10. Yep. So 21 times 5 gives us 105. We have to do 2 times 5. That gives us 10. Same as multiplying the top. I'll do this in a different color. Same as multiplying the top by 5 and the bottom by 5, because that's the same as multiplying this fraction by 5 over 5. Multiplying by 1. Over here, 35 times what is 105? Well, 30 times 3 is 90. That's close. Let's try times 3, see if that's it. What is 35 times 3? 5, carry the 1. Yep, 105. That's times 3. So we got to do 6 times 3. And 6 times 3 is 18. Again, this is the same as multiplying top and bottom by 3, because that's the same as multiplying by 3 over 3, which is the same as multiplying by 1, which doesn't change the fraction, just gives us something that's equal to it with a larger denominator. We have what we need now, 2 fractions with the same number on the bottom. So this is 10 plus 18 over 105, which is 28 over 105. Now, if you put in 28 over 105, you get that's incorrect. And that makes you sad at first because you did a lot of work to get to this point. But read what it says. Although your answer is equal to the correct answer, it is not in the correct form. That makes us feel a lot better. It's equal to the correct answer. That means everything we've done so far is correct. We just haven't reduced it all the way. So there must be something in common to both of these. What could it be? They're not both even. So it's not going to be divisible by 2 or 4 or any even number. Does 28 have any factors that aren't even? Let's try 7. $105 divided by 7. 7 goes into 10 once. Subtract, 7 goes into 35 5 times. So we just found that 105 is 7 times 15. We know 28 is 7 times 4. That means the reduced fraction And the correct answer is 4/15. And that will get accepted. Let's do another. 5/12 plus 5/9. We need two equivalent fractions. We need to find out what the bottom number is going to be. So we need the least common multiple of 12 and 9. Prime factorizations of both. 12 is going to be 2 squared times 3, because 12 is 4 times 3 and 4 is 2 times 2. 2 times 2 times 3 is 2 squared times 3. 9 works out to 3 times 3. That's 3 squared. The least common multiple is every base we have, just 2 times 3. Raised to the highest power shown. Highest power of 2 we have is 2 squared. Highest power of 3 we have is the 3 squared. So this is 4 times 9, which is 36. If you don't know your multiplication facts, you're going to have trouble with these. You need to know how to multiply and divide in order to add and subtract fractions. How do we get from 12 to 36? That's times 3. So we have to do 5 times 3. That's 15. How do we get from 9 to 36? That's times 4. So we have to do 5 times 4, which is 20. So this is 15 plus 20 over 36, which is 35/36. 5/12 plus 5/9 is 35/36. This is how you get there. Notice this is not 10/21. Let's take a look at 1/14 plus 1/35. Okay, least common multiple of 14 and 35. We need to find the prime factorizations of 14 and 35. You'll get 2 times 7 for 14. You'll get 5 times 7 for 35. So the least common multiple will be 2 times 5 times 7. Every base we have, highest powers shown are just the first. So it is 2 times 5 times 7, which is 10 times 7, which is 70. $35 to 70, that's just times 2. I'm doing that first because that was the quicker of the two. 1 times 2 is 2. How do we get from 14 to 70? Well, you can divide and find it's 5 that way, but I want to show you this breakdown of 70 we did. 70 is 10 times 7. 70 is 2 times 5 times 7. Remember, we can multiply these in any order. We did 2 times 5 is 10 first. But we could have done 2 times 7 first, which is 14. And then 14 times 5 would give us 70. So breaking this up, we can see that 14 times 5 is 70. That might be a quicker way for you to at least make sure you're checking the right numbers. And then you could actually check. 14 times 5 is what? Why, yes, it's 70 times 5. We also do 1 times 5 and we get 5. So this is equal to 5 plus 2 over 70, which is 7 over 70. And yeah, we reduced that. 7 times 1 over 7 times 10. The 7s cancel. The answer is 1/10. Not 2 49ths. Not 2 70ths. 1/10. Nine 44ths plus 19 28ths. We need the prime factorizations of 44 and 28. Notice this time, I'm going to show you the trees. 4 times 11, 11's prime. 4 is 2 times 2. 2 is prime. So 14 is 2 squared times 11. 28, that's 4 times 7. 7's prime. 4 is 2 times 2. The 2's are prime. So this is 2 squared times 7. That means the least common multiple. Every base we have is 2 times 7 times 11. Highest shown power of 2 is 2 squared. 7's to the first, 11's to the first. That's 4 times 7 times 11, which is 28 times 11. 28 times 11 is 308. So the new bottom numbers have to be 308 on both of the fractions. Joy. $44 times what is 308? Well, there's 44, 4 times 11. So it's times 7. You could always check to be sure. What's 44 times 7? 8, carry the 2, 308. We also have to do times 7 on the top. 9 times 7 would be 63. If you don't know your multiplication facts, you're going to get a different number there. 9 times 7 has to be 63. 28 times what is 308? There's 28. 28 times 11 was 308. So we have to do 19 times 11. We get 209. So this is 63 plus 209 all over 308. $209 plus 63 is 272 over 308. I know that won't be accepted. This can be reduced if for the sheer fact that both are even, which means both can be divided by 2, written as 2 times some number. What are these numbers going to be? 272 divided by 2. Make sure you're understanding every step here. If you're not, rewind, watch every step I'm doing. Make sure you know why I'm going from one to another. I'm explaining each step as I do it. All the information's here. If I'm going too fast for you, go through the problem slowly. That's why this is a recording. You can rewind me. You can pause as you're taking your notes. 2 goes into 272. 2 goes into 2 once. 2 goes into 7 3 times. 2 goes into 12 6 times. So 272 is 2 times 136. What's 308 divided by 2? 2 goes into 3 once. 2 goes into 10 5 times. 2 goes into 8 4 times. 2 times 154. So those 2's cancel. Well, these are still even. So we could at the very least divide them both by 2 again. 136 divided by 2. 2 goes into 13 6 times. 2 goes into 16 8 times. That's 2 times 68. 154 divided by 2. 2 goes into 15 7 times. 2 goes into 14 7 times. 2's cancel. I've got 68 over 77. I don't believe that goes any further. Does it accept it as the final answer? It absolutely does. 68 over 77 is our reduced fraction. Wasn't that fun? Let's do another one. We can apply our process and add 3 fractions together, which means we need the least common denominator for all 3. All 3 have to match. Prime factorizations for 2, 4, and 8. 2 is just 2. 4 is 2 squared. 8 is 2 cubed. So the least common multiple, the only base we have is 2. And the highest power shown is cubed. 2 cubed is 8. So all of these have to be rewritten over 8. And what a blessing. One of them's already done for us. The 1/8 doesn't have to change. It's already over 8. 2 times what is 8? 2 times 4 is 8. So we have to do times 4 on the top of that one as well. 1 times 4 is 4. 4 times what is 8? That's times 2. So we have to do times 2 on the top as well. 1 times 2 is 2. And this one didn't change, but we could still walk through it the same way if we want. 8 times what is 8? Times 1. So we do times 1 on the top as well. 1 times 1 is 1. So this would be 4 plus 2 plus 1 all over 8. 6 plus 1 makes 7. So the answer is 7/8. Let's do another. Which of course will be a little more complicated. We're not going to get to keep one of our fractions this time. 2/3 plus 2/9 plus 3/4. So we need prime factorizations for 3, 4, and 9. 3, 9, and 4, and that'll help us find the least common multiple. 3 is just 3. 9 is 3 squared. 4 is 2 squared. All the bases we have are 2 and 3. Highest power shown for 2 is 2 squared. Highest power shown for 3 is 3 squared. That's 4 times 9. That's 36. So each of these has to be rewritten over 36. Three times what is 36? Well, that's 3 times 12. So we do times 12 on the top as well. 2 times 12 is 24. 9 times what is 36? That's times 4. So we have to do times 4 on the top as well. 2 times 4 is 8. 4 times what is 36? That's times 9. So we have to do times 9 on the top as well. 3 times 9 is 27. So on top, 24 plus 8 plus 27, all over 36. 24 plus 8 is 32. So 32 plus 27 all over 36. 32 plus 27 is 59. So 59 over 36, which is accepted. Isn't this fun? I think these are kind of fun. Let's look at 57 over 100. Plus 3/4. Plus 9/10. 100. We look at the factor tree, that's 10 times 10. Each of those 10s is 2 times 5. 100 is 2 squared, 5 squared. 4 is 2 squared. 10 is 2 times 5. That means least common multiple. Only bases are 2 and 5. Highest shown power of both is squared. 4 times 25 makes 100. Woohoo, one of them gets to stay the way it is. 57 over 100 is already what we need. For 4, we would have to do 4 times 25 to get to 100. So on top, 3 times 25 would be 75. 10 times 10 to make 100. So times 10 on top, 9 times 10 is 90. This is 57
plus 75 plus 90 all over 100. 57 plus 75 would be 132. 132 plus 90 over 100. And then 132 plus 90. 222 over 100. And a funny thing happens when we put this in. There wasn't any mixed number in the problem. We have had answers of improper fractions before, and it was fine. This time, it says that's incorrect. And that's because we have that special instruction I warned you about last time, where it says type a whole number fraction or mixed number. If it specifically says that a mixed number can be put in and we get an improper fraction, it will only accept a mixed number. So we have to divide 222 divided by 100. 100 goes into 222 twice, with 22 left over. If we put in 2 and 22 100ths, it still tells us the same thing. What did we do wrong? We converted it to a mixed number. 22 over 100 can be reduced. 22 is 2 times 11. 100 is 2 times 50. The 2's cancel, so this is actually 2 and 11 50ths. And sure enough, that one will be accepted. So remember, it's not enough to change it to a mixed number. The fraction piece of it still needs to be reduced. 2 and 11 50ths. Let's do another. I promise we'll do some subtraction before we're done. Let's look at 3 28ths plus 3 35ths plus 7 20ths. Remember, addition and subtraction is all the same. Only difference is at the end whether we're adding across the top or subtracting across the top. Prime factorizations. 28 is 4 times 7. That's 2 times 2. 28 is 2 squared times 7. 35, that's 5 times 7. Both of those are prime. 20, it's 4 times 5. 4 is 2 times 2. 20 is 2 squared times 5. Once we have the prime factorizations, we can find the least common multiple. Every base we have is just 2 times 5 times 7. Highest power of 2 we have is 2 squared. Highest power of 5 and 7 are just the first power. That's 4 times 5 times 7. 20 times 7. 140. So all 3 of these fractions need to be rewritten as fractions over 140. Notice once we wrote this out, 4 times 5 gives us the 20, 4 times 7 gives us the 28, 5 times 7 gives us the 35. Knowing that 140 is 4 times 5 times 7 will help us here. 28 times what is 140? There's the 28, 4 times 7. So times 5. Whatever we do on the bottom, we have to do on the top. 35 times what is 140? Well, there's the 35, 5 times 7. So times 4 makes the 140. Whatever we do on the bottom, we do on top. And then 20 times what is 140? 4 times 5 is the 20. So times 7 gives us the 140. Whatever we do on the bottom, we have to do on top. Again, that's why we get equivalent fractions, because times 5 on top times 5 on the bottom is times 5 over 5. That's times 1. Times 1 doesn't change the value. Just makes it look different when we do it times 5 times 5. 3 times 5 is 15. 3 times 4 is 12. 7 times 7 is 49. So this is 15 plus 12 plus 49 all over 140. That's 17 plus 49 over 140. Sorry, not 17, 27. 27 plus 49. And 27 plus 49 is 76. 76 over 140. Well, it's not improper, so we don't have to worry about a mixed number, but both are even, so it at least reduces dividing both by 2. $76 divided by 2. 2 goes into 7 3 times. 2 goes into 16 8 times. So that's 2 times 38. 140 is 2 times 70. The 2's cancel. But 38 and 70 can both be divided by 2 again. 38 divided by 2 is 19. 70 divided by 2 is 35. So it looks like we have 19 over 35. Which is accepted. Five sixths minus 5/12. And this isn't 0. At no point are we doing 5 minus 5, because these numbers are not the same on the bottom. We can't add or subtract until the numbers on the bottom are the same. But if we do times 2 and times 2, because the least common multiple of 6 and 12 would be 12, that turns these into 10/12 minus 5/12, which is 10 minus 5/12. Our answer would be 5/12. So again, when the least common multiple is already one of the numbers, it's quicker just to think, how do we multiply up the other one and just do that? We could still do LCD method. And in this next one, we're going to do LCD method. By the way, if you've noticed that I'm switching back and forth between LCM and LCD, LCM is least common multiple. LCD is least common denominator. And in this case, they're interchangeable because the least common denominator is just the least common multiple of the two denominators. So those two numbers on the bottom, when we're finding the least common multiple of them, we're actually finding something called the least common denominator. But you may have noticed I'm trying to avoid words like numerator and denominator. I know you know that numerator is the top number, denominator is the bottom number. But why repeat these 5-syllable, 4-syllable words when I can just say top and bottom? Gets us through more problems quicker. More examples we see, hopefully the better we feel. Hopefully, even if you're a little concerned about all the multiplication and division involved in these addition and subtraction of fraction problems, you're feeling better about the process. Five is just 5. 6 is 2 times 3. The least common multiple of these numbers would be all the bases we have, 2 times 3 times 5, raised to the highest powers we have. That's just the first. 2 times 3 is 6, times 5 is 30. These need to be rewritten as fractions over 30. How do we get there? Well, it's times 6. 5 times 6 is 30. Whatever we do on the bottom, we do on the top. 6 times 5 is 30. Whatever we do on the bottom, we do on the top. 4 times 6 is 24. 1 times 5 is 5. This is 24 minus 5 all over 30, which is 19/30. Let's take a look at 3/5 minus 1/7. 5 is just 5. 7 is just 7. So the least common multiple is just 5 times 7, 35. Two fractions over 35. How do we get there? 5 times what is 35? Times 7. Whatever we do on the bottom, we do on the top. 7 times what is 35? 5. Whatever we do on the bottom, we do on the top. 3 times 7 is 21. 1 times 5 is 5. 21 minus 5 over 35 is 16 over 35. Nine 14ths minus 4 9ths. 14 is 2 times 7. 9 is 3 squared. The least common multiple would be 2 times 3 times 7, raised to the highest powers shown. Highest power of 3 is 3 squared. The rest are 2 to the first and 7 to the first. That's 2 times 9 times 7. That's 18 times 7. And that's a problem for doing by hand. 7 times 8 is 56. Carry the 5. 7 times 1 is 7. Plus 5 is 12. 126 is the least common multiple. 2 fractions over 126 instead of over 14 and 9. How do we get there? 14 times what is 126? There's the 14, so times 9. Whatever we do on the bottom, we do on the top. 9 times what is 126? There's the 9. So 9 times 2 times 7, 9 times 14. Whatever we do on the bottom, we do on the top. 9 times 9 is 81. 4 times 14 is 56. This is 81 minus 56 all over 126. 81 minus 56 is 25. Over 126. Okay, I'd like to do one final problem. Let me pick a good one. Why not? Gonna skip to the last one. It's as good as any. 37 over 52 minus 5 over 28. I know we did a lot more addition than subtraction, but I'll say it one last time. It's the same thing. 52. Let's do a factor tree. It's 26 times 2. 26 is 13 times 2. So 52 is 2 squared times 13. What about 28? Twenty-eight is 2 times 14. 14 is 2 times 7. So that's 2 squared times 7. The least common multiple would be 2 times 7 times 13. That's all our bases. Raised to the highest shown power. So the 2 is squared, the rest are to the first. Least common multiple is 4 times 7 times 13, which is 28 times 13. Ooh. This is why you need to know how to multiply. 8 times 3, 4, carry the 2. 6, 8, 4, 8, 2, 364. So 364 becomes the new number on the bottom. How do we get there? 52 times what? Well, 4 times 13 is the 52, so this is times 7. Whatever we do on the bottom, we do on the top. 28 times 13, whatever we do on the bottom, we do on the top. 37 times 7 is 259. 13 times 5 is 65. This is 259 minus 65 all over 364. $259 minus 65. That's 194 over 364. We can reduce. 194 divided by 2 is 97. $364 divided by 2 . is 182. Is 97 over 182 acceptable? It is. So 97 over 182 doesn't reduce any further. Okay, so now you know how to add and subtract fractions.
Let's kick it up a notch. 5/8 minus 1/3 minus 1/12. We need the LCD of all three fractions of 8, 3, and 12. If we start with the greatest number, that's 12. 12 is not a multiple of both 8 and 3. It is a multiple of 3, but not of 8. 12 times 2 is 24. 24 is a multiple of 8. 24 is a multiple of 3. The LCD is 24. Or you can take your prime factorizations. 8 is 2 times 2 times 2. 3 is 3. 12 is 2 times 2 times 3. The most number of 2's we have is 3. The most number of 3's we have is 1. 2 times 2 times 2 times 3 gives us 24. So we want to take our fractions. We want to rewrite them all so that they are fractions over 24. To turn 8 into 24, that's times 3. Times 3 on the bottom is times 3 on top. To get from 3 to 24, that's times 8. 8 multiplied on the bottom means 8 multiplied on top. And to get 12 to 24, that's times 2. Times 2 on the bottom means times 2 on the top. Simplify this, we get 15 24ths minus 8 24ths minus 2 24ths. Keep the 24 on the bottom, subtract along the top. 15 minus 8 is 7. 7 minus 2 is 5. So 5 24ths. Since we can do this with numbers, we can do this with letters. We can do it with variables. 5 minus y over 4. 5 is 5 over 1. The LCD, the least common multiple of 1 and 4, is just 4. So rewrite 5 over 1 as a fraction over 4. 1 times 4 gets us 4. Times 4 on the bottom means times 4 on top. 5 times 4 is 20. So 20 fourths minus y fourths. Keep the 4 on the bottom, subtract along the top. 20 minus y is just 20 minus y. We can't take it any further. So 20 minus y all over 4.